see we have another polar coordinates 2 and negative pi over 4. So let's first get angle. Okay, this is the pi over 4, right? And then this guy is the negative pi over 4. And since this 2 is positive, we just locate the 1 point which is the 2 units away from the pole, but in the terminal side of this angle, right? So 2 units away from the pole is here. And this is a point with the 2 and negative pi over 4. Now, how about negative 2 and pi over 4? So you still begin with the angle pi over 4, and then on the extension of this terminal side, you locate 1 point which is 2 units away from the pole. So this is the direction opposite to the point 2 and pi over 4, right? So 2 units away from the pole, so it's here. So this guy is the point with the polar coordinates negative 2 and pi over 4. Now, how about 2 and pi over 4 plus pi? And we know actually this angle is just the pi over 4 plus pi, right? So this is the pi over 4 plus pi. And then you locate 1 point which is away from the pole by 2 units. So actually you got the same point as the negative 2 and pi over 4. So you can write its polar coordinates next to this point. You have the 2 and the pi over 4 plus pi. So now you notice one important thing about the polar coordinates. That is, we don't have the 1-to-1 correspondence between the points in the plane and the polar coordinates. This is quite different from the rectangular plane, right? In the case of the rectangular plane, we have the 1-to-1 correspondence between the points and the pair of the coordinates. For example, you have the points here, right? And then its coordinates is AB. Then between this point P and AB, so between the points and the pair of the coordinates, you have the 1-to-1 correspondence. Okay, you have this 1-to-1 correspondence, right? But in the case of the polar coordinate system, no 1-to-1 correspondence between the polar coordinates and the points in the plane. So no 1-to-1 correspondence between the polar coordinates and points in the plane. So this is a big difference between the polar coordinate system and the rectangular coordinate system. And you can also see some other examples about how to locating the point by using the polar coordinates. So I just stop here. So last time we talked about the nth roots of a complex number. Suppose we have the equation z to nth equal to a plus bi. And here we write the z and also the a plus bi in the trigonometric form. So z is equal to s times cosine alpha plus I times sine alpha, and a plus bi equal to r times cosine theta plus I times sine theta. And we know this argument alpha and theta are not unique, right? You may have the infinity many values for them. Just take one. So when we try to solve this equation for z, then we get such solution. So s first is equal to r raised to the nth root of r, right? R raised to the 1 over n. And then alpha is equal to 2k pi plus theta over n. And we know for a polynomial equation, the number of the roots is equal to the degree of this polynomial. For this one, the variable is z, so the degree of this polynomial is equal to n. So totally, we have the n roots. So that means we just let the k equal to 0, 1, 2, through the n minus 1. Then we can find all those n roots. Okay, if you take the other integers for k, you just get the repeated roots you already got in this, okay, n roots. So this is the stuff we learned last time. And if you have the equation C, you have the z to the n equal to a real number, for example 3. How do we write the real number, say this positive 3, in the trigonometric form? Actually, it's quite easy. You may just plot the 3 in the rectangular plane, also in the complex plane. You know, 3 is here, right? So you can see its argument. The argument is just 0. So the argument for 3 here is equal to 0. Then the modulus of 3 is just itself. So here 3 is equal to 3 times cosine 0 degrees plus I times sine of 0 degrees. If you still want to use the formula for finding the argument, you may do it in such a way. Say in this guy, 3 is equal to 3 plus I times 0, right? So that means you have the A equal to 3 and B is equal to 0. And then your R is equal to the square root of A squared plus B squared. So this is just equal to 3, right? So now the sine theta is equal to B over R. So it's equal to 0 over 3, okay, equal to 0. So this just implies you may take theta to be, okay, 0 degrees. Then in this way you find the argument for this real number.